Okay, hi class. We have a question here. The question is calculate the pH and the concentration of all species present in 3.20 times 10 to the negative fifth molar concentration of acetic acid. The Ka value is provided. Now recall, typically whenever we try to solve the ice problems for weak acids, we end up using an approximation. And I told you in class that it's a possibility once in a while you might be given initial concentrations that are low enough that at that point of time you will not be able to use the approximation, and you will end up solving the quadratic. So let's take a look at the steps one more time. First off, you should be able to write down the equilibrium reaction, and the equilibrium reaction is basically based on the dissociation of acetic acid here. So I have CH3 COOH, which is being reacted with water, and that's an equilibrium to give you acetate and hydronium ion. Because it's an acid, hydronium ion will always get generated. So acetic acid, that's going to have an AQ by it. Water is a liquid. Acetate is an AQ. Hydronium is an AQ as well. Now, you know that when we try to write down the Ka, that is going to be the concentration of the products times concentration of the reactants divided by concentration of the concentration of the products, both of the products divided by the concentration of the reactants. We're not going to introduce water in here because it's in the liquid phase. So if you had to now set up the ice for this, so initial, change, and then equilibrium, you would say that in the beginning, everything that acetic acid is used and the initial concentration is going to be present as acetic acid by itself. And as time passes by, a little bit of acetate is going to get generated. So the change is going to occur. Since it's a 1-to-1 mole ratio, the change is going to occur. So if there are X moles of acetic acid that underwent dissociation, X moles of acetate and X of the hydronium will get generated. And so at equilibrium, it can be said what will remain will be 3.2 times 10 to the negative fifth minus X. X of acetate and X of the hydronium would have gotten generated. So we have our numbers now. What we are going to do is now plug these numbers back into the definition of Ka. And so hopefully you can see. Let's switch the color a little bit brighter. So X for the acetate, X for the hydronium, divided by 3.2 times 10 to the negative fifth minus X. And this value, by the way, is going to be equal to 1.7 times 10 to the negative fifth. Now, let's try to solve, see first off whether the approximation is going to hold true or not, and take it from there. So, let me make some more room. If I try to simplify the equation a little bit more, I can write down for myself that X squared divided by 3.2 times 10 to the negative 5 minus X should be equal to 1.7 times 10 to the negative fifth. And so now we are going to apply our 5% approximation. There are various ways to say the same thing. What we are basically doing is we are looking at the concentration that we have been given, and we are going to divide that by the value of Ka for that acid, and we are going to see what that number comes out to be. 3.20 times 10 to the negative 5 divided by 1.7 times 10 to the negative 5 as well. 10 to the negative 5 is going to cancel off, and this is approximately twice. My guess would be 1.85-ish or so, which is not very small or very big than 100. It is not. So this is in the same order as 100. So the approximation does not hold true. No approximation can be used in this case. That means you will end up solving your quadratic equation. And what that means is that your equation now should start looking like, if I cross multiply, another way to say this, this would be multiplying both sides by 3.2 times 10 to the negative 5 minus x. So this is going to look like x squared is equal to 1.7 times 10 to the negative 5, and in parentheses you have 3.2 times 10 to the negative 5 minus x. That's what we have. So let's simplify it more. And you can say x squared is equal to 5.44. That's what you would get when you multiply the 1.7 and the 3.2 together. So 5.44, the powers are going to add up, times 10 to the negative 10 minus 1.7 times 10 to the negative 5 x. And so since the nature of a quadratic equation is always of the kind ax squared plus bx plus c equals 0, that means you want to bring in all of your x terms on one side. And right now the way I haven't quite set up in that manner. So that's what I'm going to do now. And I can say that x squared plus 1.7 times 10 to the negative 5th x minus 5.44 times 10 to the negative 10 is going to be equal to 0. So this is my quadratic equation. So all I have done is I have transposed the x terms on the other side of the equation so that I can see that in the same format as the ax squared plus bx plus c. And when you do that, now you would be able to write down the solutions for the equation. Turns out that the solutions of a quadratic equation are known to be minus b plus minus square root of b squared minus 4ac divided by 2a. And so that's what we are going to apply over here. So that means if my quadratic equation is of the kind ax squared plus bx plus c equals 0, I will be able to figure out my solutions by looking at minus b plus minus square root of b squared minus 4ac divided by 2a. And so I'm going to find my solutions and solve for the value of x and see if it actually pans out. Realize what is x ultimately. X is a concentration. So if one of these numbers comes out to be a negative number, well, realize you cannot have a negative concentration, so you will just have to just neglect that and use the positive value. So let's take a look in a little bit more detail. And what I'm going to have now is 1 times x squared, so the value of a is 1, plus bx, that means this number is b, plus c, that means this number is c. So I'm comparing the two equations and I got my values of a, b, and c. And so I'm going to write down both of my numbers, and I can say that negative 1.7 times 10 to the negative 5th plus minus square root of b squared, that would be 1.7 times 10 to the negative 5 square of that, minus 4 times 1 times negative 5.44 times 10 to the negative 10 whole divided by 2 times 1. So that's what I have so far. Okay, now realize, like I said, when you solve this entire number, since it's plus minus, one of these numbers, so basically you're carrying out two solutions, one of these equations is going to provide the value of x, which will come from the operator, and I'm going to put down the whole thing. 1.7 times 10 to the negative 5 square of that minus 4 minus 5.44 times 10 to the negative 10 divided by 2. So realize that whatever this number is, whatever that number is, even if it's a positive number, even this is a positive number, what's under the square root, since that is negative and there is another negative number, that number will always remain negative. So this solution of x can be omitted. So I'm not going to work on the solution because this is a negative number, and the x basically portrays a concentration, and that can never be negative. So what I am going to work on as a solution is this operator, 1.7 times 10 to the negative 5, and I'm going to just use the plus operator now, times 10 to the negative 5, square of that, minus 4 minus 5.44 times 10 to the negative 10 divided by 2. And let's see where we go from there. So my equation becomes negative 1.7 times 10 to the negative 5 plus square root of 1.7, square of that will be 2.89 times 10 to the negative 10 plus 4 times 5.44 is 21.76 on my calculator, times 10 to the negative 10 divided by 2. So that gives me a value negative 5 plus square root of, on my calculator I have 24.65 times 10 to the negative 10 and square root of that. So 24.65 is what came from the addition of the 21.76 and the 2.89. And when you take the square root of that, that will look like 1.7 times 10 to the negative 5th plus 4.96 times 10 to the negative 5th divided by 2. So when you solve this value, let's switch color. When you solve this value, you're going to see 6, 2, 3 times 10 to the negative 5 divided by 2, and that gives you a 1.63 times 10 to the negative 5. So your value of x came out to be 1.63 times 10 to the negative 5. And that means, what was x? The value of x was basically portraying the concentration of the hydronium and the concentration of acetate. Because recall our original equation that we wrote was the equilibrium of acetic acid with water gives you acetic acid with water gives you acetate and hydronium, and we had assumed these values to be x, and that came out to be 1.63 times 10 to the power of minus 5 molar. And if you recall, the acetic acid initial concentration was given, which was 3.20 times 10 to the negative 5, and so at equilibrium, this number minus x is what remains. So 3.20 times 10 to the negative 5 minus 1.63 times 10 to the negative 5, and that would mean that you would have 1.57 times 10 to the negative 5th molar as the concentration of acetic acid. And now if somebody says that you had to determine the pH also, all you got to do is take the negative log of the hydronium ion concentration, which is 1.63 times 10 to the negative 5. So on your calculator, you should put in the number, hit log, and I am getting a value of 4.78. It's the log to the base 10, not the natural log that you're supposed to put in. And I know that that answer is accurate because according to the rule of logs, this equation can be written as minus 5. From that, if you subtract the value of log of 1.63, you're going to get that number. So 5 minus some number, and this is going to be 0 point something because it starts at 1, and that would be a number between 4 and 5, and so we are getting a value of 4.78. So that means I punched in the data accurately. Hope this helps in realize this takes a little bit longer time in solving the entire quadratic equation, which is why I told you guys in class that this is not something that I'm going to put it on a test, but you should know how to solve that for the perspective of a dry lab.